Hi boys, this is another radical lesson that involves simplifying with radicals. So if you are not comfortable with simplifying radicals, please review prior videos that I have shown from chapter 11, section 2. This one is dealing with adding and subtracting radicals, and it is very similar to how you would add like terms together. So for example, how you can say 5x plus 2x is equal to 7x, or 2x plus 7x squared stays as 2x plus 7x squared because the variable and exponent isn't the same. The idea carries through with radicals, so you can only add the, let's say, term in front of the radical symbols if the radicals are the same. So looking at number 1, I have 4 root 10, root 13, not minus 9 root 10. There are only 2 radicals that can be combined together, and that is 4 radical 10 and negative 9 radical 10, because they both have the same radical, so you are able to combine 4 minus 9 together. I can't add root 13 to either of these radicals because they aren't the same. You also do not add radicals together. So to start to solve this answer, if I have 4 radical 10 minus 9 radical 10, 4 minus 9 is negative 5, and then radical 10 stays as it is. Again, think of when you combined variables together. You didn't do anything with the variable itself. If it was x, it stayed x. If it was y, it stayed y. And then since radical 13 does not have a common radical with anything else, it will just be negative 5 root 10 plus root 13 as your final answer. So you're pretty much looking for radicals that are the same, and then if they are, can you add or subtract them from one another? Now, when there are radicals, so in number 2, where we have a radical 3 and a radical 48, obviously those two numbers aren't the same. You want to see that if I simplify one of these radicals, meaning can it be broken down because there's a perfect square within the factors of a number, are we going to get a radical 3? So radical 3 can't be reduced because it's a prime number, but radical 48 can be reduced. So we want to think, well, I want something that has a radical 3. So does 48 have a factor of 3? Yes, it does. If I break this down, and again, that's where you want to review those videos that I had shared on how to simplify radicals. I know 3 goes into 48 evenly because 48 divided by 3 is going to be 16. So I see a radical 3 coming in, so I can start to rewrite this radical 48. I also know that the square root of 16 is a perfect square. So what I can do is rewrite 5 root 3. And now instead of adding just the radical 48 to it, I'm now adding the square root of 16 is 4, and radical 3 can't be simplified, so it stays as is. And now if you notice, we have the same radicals, so we're allowed to add together 5 plus 4, which is 9, radical 3. Do not add the radical values together. I took this right from your textbook. I wonder if I have the textbook open. I think I do. Hold on, let me view that for you guys. I took this right from your textbook on page 721 because I really liked those two examples. And it also shows you what they did. They break their radicals down a little bit differently. And up here, they kind of regrouped things into the distributive property, which I don't necessarily think is needed for showing your work. But when we do show our work, I need to see if you rewrote something, how did you do that? Or if you combined radicals together, please underline or circle them. So good luck. I hope this lesson is a little bit easier than our prior radical lessons.